session. For this session, I would like to invite my colleague Bernhard Hirschmann, who is joining us from beautiful Austria. Good afternoon, Bernhard.
Good afternoon, Daria. Hello. How are you
Hi,
doing?
I'm doing well. How are you today?
I'm perfectly fine. I'm excited.
Ready for the presentation?
Absolutely. I can't wait.
Very good. Everyone, Bernhard is going to talk today about cobalt-free dryers. You can start asking your questions using the Q&A chat that is there on the right-hand side of your screen. Bernhard, good luck, and everyone enjoy the presentation.
Dear listeners, I'm excited and I'm thrilled to spend the coming half hour together with you. I thank you all for staying tuned these 3 days and keeping up with us. As we are almost at the end of the Sustainability Conference, I'd like to invite you to my session, Health Goes High Tech. In recent years, archaeologists found stunning drawings in a cave in South Africa. Those drawings dating back over 30,000 years in time. These early paints consist out of natural fat from animals and earth as a pigment. It eventually was the first air drying paint system in the world. These ancient paints had almost the same ingredients and compositions as modern air drying paints. However, it took just ages for them to dry. So let's have a look at the more modern air drying paint systems and where those air drying paint systems are applied. There's a big variety utilizing air drying paints, such as in architectural enamels and trim paints. The old world of wood finishes, whether they are clear, transparent, or pigmented. The world of oxidative drying industrial paints uses alkyd paints. There is also utilization in most of the marine and protective enamels. And not to forget, the big world of inks is using a big portion of unsaturated air drying paints. When we want to divide these technologies into the world of waterborne and solvent-borne systems, yes, we do have the clear alkyd paint systems. We do have the urethane alkyds and urethane oils, and also modified alkyd systems, as well as a big utilization in epoxy esters, varnishes, and of course not to forget the world of natural oils, bio oils that are used in most of the wood stains and impregnations too. We have to look a little closer to the details of air drying and how an alkyd paint is drying in stages. Well, there are two stages, in fact, where an alkyd paint dries. Number one, this is the physical drying. You have to understand that once you apply the liquid paint, the solvent, whether this is an organic solvent or even water, starts to evaporate. And the paint particles, they form a film via coalescence effects. Then after that, a chemical drying process starts. It is called the oxidative drying stage. A lipid material that oxidizes by the uptake of oxygen from the air and forming a macromolecular paint. As much as I want to avoid, we have to talk a little chemistry here. And to keep it simple, I went for the example of a basic linoleic acid here. The linoleic acid is a polyunsaturated omega-6 fatty acid with two double bonds that are interrupted by a methylene group. And when we have a dryer metal here, the dryer metal has different functions. The first function actually is to bring the molecular oxygen from the air in all the coating layers, from top to down. And the second action is then that the metal dryer forms a hydroperoxide with this oxygen taken up earlier. And the hydroperoxide later on decomposes, and it decomposes following the redox reaction, following the Haber-Weiss principle. This is a very fast reaction actually, and the result is that there are radicals formed. These are either oxoradicals or pair oxoradicals. And these radicals are then able to attack another fatty acid with double bonds and form a three-dimensional network. This process, once this has started, is a self-continuing process, an autopolymerization. And the faster this autopolymerization stages forward, the faster the alkyd paint is dry. Well, let's talk a little more about the oxygen transition and how the oxygen does get into the paints. Well, we have a categorization of Driers, which we follow the periodic table of the elements. So, and we have to look to the right place of the table of the elements, where we find all the transition metals. And there is a variety of transition metals. However, I do focus on the most relevant here. And yes, you see the cobalt immediately popping up. Why? Because cobalt still is historically and still is the most important and widely used primary drying metal. The positive end on the cobalt is it gives a very strong surface dry. So that is important for dust and tag-free effects. Huh? It also, when we talk about the discoloration and yellowing, it has a low tendency to yellow. And by nature, the cobalt is appearing as a bluish color, and the bluish undertone is always seen as a nice discoloration. However, the fast mode of action in the early drying stage causes an effect which we call skinning or wrinkling. And this is absolutely unliked in the world of paint formulators. Cobalt as such has a little less good through drying effect, so through all the paint layers. And the problem with cobalt at the end of the day that it is reclassified as a reprotoxic material following the CLB regulation as category 2. Now, moving to another element there is manganese. Manganese is a very interesting replacement for cobalt these days. It has a little longer induction time because this first differential decomposition of the hydroperoxide is taking longer time compared to cobalt. However, we see a very good through drying performance with manganese and also a little less risk of wrinkle and skin formation. However, on the other side, the manganese gives us a little stronger discoloration aspect. It's not stronger than cobalt, but it has a different color, as the manganese in different oxidation stages is appearing as a yellow to brownish undertone. That brings me to another metal, which is iron. And iron is a metal where you can form a dryer with that is very efficient at room temperature, lower efficiency at room temperature, and mostly used in aqueous system. However, when we use it in aqueous system, we see a negative effect for the corrosion performance. The positive end on the iron is that we see the best rates of discoloration. So the paint would stay very neutral in color. Not enough that we are talking about the primary drying metals, we have to try also about the supportive drying metals. And those are auxiliary dryers actually, which we need in some paints and some requirements to support the primary metal. And this is mostly when we have paints that are applied with a brush or roller in a relatively high film thickness. And the first metal to be mentioned here is zirconium. Zirconium actually is very good because it has the lowest discoloration rate, and it is of course used mainly together with cobalt or manganese as a primary drying soap. It gives us a very good through drying effect and can be combined also with lithium as a secondary dryer. Before I come to the lithium, let me give a second on the barium. The barium is interesting because it doesn't give this strong effect on the drying as such. It leaves a little longer time the paint to form a film, to make a nice flow and leveling effect, and that results by nature in a better in a better optical appearance of the paint surface. It's got a good support of through drying, so that meaning it transports a lot of oxygen into deeper coating layers. All is good, but nothing is as good as the lithium. the lithium actually works very good also in high solids and the modern waterborne alkyd paint systems. It has a strong effect of reducing the wrinkling and high film buildup systems, and the lithium is the element that helps us with low temperature curing. And we are not only speaking about room temperature, we are also speaking about alkyd paints that are used in the Scandinavian region, where we have drying conditions from 10 degrees to 5 degrees above zero. Well, here we are. This probably is one of the most important slides in my presentation. It's all about the concerns of cobalt and why cobalt is today in strong discussions, and not only today, already since, I would say, a decade, cobalt is in negotiations and discussions for becoming a reprotoxic material in the world of paints. There are cobalt as an elementary cobalt, but also cobalt as soaps, as different soaps like a borate or neodecanoate complexes or neodecanoic acid complexes that are under strong concern for the health of people when they are using DIY paints from any home markets, for example. So how does this classification goes on actually? So what the status is of today, all these all the materials mentioned on the left side, they are categorized as category 2 following the H361 sentence, following the European CLP regulation. Cobalt, on top of this, is expected to be reclassified as a carcinogenic material following the CMR category 1B classification. And as soon as this stage is progressed in REACH and ECHA, we have a different problem here, another problem, which would mean that the final utilization and dosage of cobalt in a ready-to-use formulation has to stay lower than 0.1%. Which means in extensive tests in our in-house labs, but also with our external partners, there was no paint working formulated with a content of cobalt less than 0.1%. That being said, if this classification into category 1 takes place and being efficient, cobalt and cobalt materials, such as on the left side, becomes substances of very high concern. And this is something even our paint manufacturer are very hesitant to use this material any further. So cobalt continues to phase out the market in European Union and Europe, but not only there, also in other countries like the USA or China, there are strong ambitions to avoid cobalt being used in any further paint design of oxidative drying paints. So what are we doing now, right? There are alternatives on the market already. That's a good thing. And I start with the curiosity. You can replace cobalt by cobalt. This is probably not the best way you might think, and I would agree in a certain way. What we talk here is the cobalt polymer. So cobalt polymer, according to today's regulations, so CLP and CMR, is okay to be used in paints. The problem is more on the marketing side or on the future thinking of customers and sustainability thinking, because if you replace cobalt with cobalt, you still have the cobalt as an atom there. And this is actually only one disadvantage. The second disadvantage is to get the cobalt polymer as efficient as a cobalt metal, you need higher dosages, and higher dosages result into higher formulation costs. So that's why a lot of people are looking also more to the right side, and let's stay there a little bit with the iron. The iron complex dryer is something very acceptable for waterborne alkyd paints. However, the compatibility in solvent-borne high solid alkyd paints is very difficult and sometimes even not given. There is a negative impact as well on the waterborne side when we talk anti-corrosion performance, because the iron is actively promoting the corrosion, and this is something very negative for direct to metal corrosion, anti-corrosive paints. In general, the iron Generation 1 and the manganese Generation 1 replacement dryers have a problem with the performance loss during the paint aging. This is something we have to consider here. So manganese on the right side has a good gloss retention. It has acceptable discoloration rates, a little yellow here and there. So it's very good for undercoats and primers, but not so good in the utilization for top coats. So there we are actually, and what have we done, or what can we do better here? We have designed a couple of new materials, avoiding cobalt, using manganese as a complexing metal, but using a different composition or a specific composition of one or more complexing partners, accelerators, and ligands actually. The products we have in place here are called ADDITOL, CF100 and CF103. So both of them are cobalt-free. They use an IP-protected multi-acceleration system, and this acceleration system actually overcompensates the weakness of manganese in the first drying stage, which we call set drying. Both dryers are absolutely universal, can be used both ways in waterborne and solvent-borne and high solid systems, and would give an extremely fast polymerization rate and reducing the tendency of skin formation, which ends up in less consumption of anti-skin additives. If you want to boost these dryers any further because you have a very high film build, you could use one of the co-designed auxiliary dryers. They are called ADDITOL Dry CF200 and 300, and using different secondary dryer combinations such as lithium, barium, and zirconium. So this is sometimes helpful for waterborne and high solid systems or ultra high solid systems. The one on the right is a system we have already traditional for longer time on the market. It's one of the best dryers we see in heavy duty or mid duty corrosion protection direct to metal applications. So actually, it's all about your choice. I mean, we are guiding our customers, our formulation partners with different stages of the cobalt exit. So we have a waterborne, or how to say, water emulsified cobalt containing materials. We still have the phase 2 of cobalt polymeric dryers, until we come to the real cobalt-free materials, which you see on the right side of the screen in green, which I have just explained to you. I would want to show you one of the testing results we did, and this is one of the most important testing results we can show to our formulators and customers, is the loss of dry effect. So when you have the paint and you put it to your shelf, usually the dryers tend to adsorb on pigments. Surprisingly, it goes very strong on titanium dioxide and inorganic pigments. And there we see a strong drift of performance when we compare the testing right after the paint production, but then anytime later at elevated temperature storage. And after 3 weeks of temperature storage, we see a big difference in dryer performance. So actually, that's where we wanted to be with our new dryers, to have the full performance available in a paint that already stands for some time on the shelf at the customers, for example. A test result here was performed in a very modern, high solid, long oil white alkyd paint. So actually, these are one of the most different paint systems, and they are co-accelerated with calcium and zirconium. So when I come to the end of my presentation slowly, I want to summarize the most crucial conditions for an air drying alkyd paint and the requirements for the dryer. So first of all, the dryer has to be very good with the set dry. So this is, remember, the first stage of drying right after the application of the liquid film. Then the through drying taking place anytime later after the set drying, and is also responsible at the end for the hardness development of the paint. The discoloration, as it is important because we are all in use of white, bright white exterior paint systems. The skin formation, which is always a nightmare because you have to use the anti-skin additives and we have to go in future outside the mycosystems. And this is something we have to pay attention. We have to pay a lot of attention. The compatibility to waterborne systems, but also to solvent-borne systems in the same time. The anti-corrosion effect, because as I said, most of the systems are applied also on direct to metal. And the post-storage performance. So what happens with the paint when you leave it in the corner and want to have still performance after a while? And of course, all the modern aspects like a low VOC or near to zero VOC and a high flash point for safe handlings in the world of inks, for example. And when we then see the green line and the blue line, I think we can outperform most of existing technologies in the market. You change to the two new ADDITOL grades and you are safe in most of the topics mentioned here. And this is what makes the new development of cobalt-free dryers by using specific ligands that much of interest. Finally, there are guiding formulations, there are guiding systems, of course, and we took two very well-known systems from our in-house resin partners actually and made those formulation cobalt-free by using one of the new dryers. On the left side, you see a brushable glossy white paint, and that is using the ADDITOL Dry CF100 as a primary dryer and just a tiny amount of calcium as a sacrificial dryer, which is state of the art today. When you look to the right side, there's a very modern direct to metal glossy anti-corrosion monolayer paint. And this one, we use the CF100 as a primary dryer. And as a secondary dryer, because sometimes that goes higher film thickness, we use the lithium zirconium mixed dryer. So dosages is always important for our customers. You can add those dryers, first of all, in any stage of the paint production stage, and the dosages are extremely low. If you remember the dosage of cobalt or cobalt polymer dryers, so they are around about 10 times as high as we need to dose with our new cobalt-free dryers. So cobalt-free dryers are something that can reduce the cost of the formulation, improve the performance, and only in the world of ultra-high solids, we need a little bit higher dosage of the cobalt-free dryers. With that, I thank you for your attention. I'm open for any questions now, and I'm happy to answer that.
Thank you very much, Bernhard, for presenting. And now it's time for questions. And let me start with this one. I would like to ask you the following question. Is there any latest update on cobalt regulation in Europe? And by when will cobalt be gone and no longer available for the coatings industry?
Mm-hmm. Yeah, thank you for that question. Actually, what I did before I brought up this presentation, I was exchanging with the ECHA. So we have our PSRA specialist. I'm engaged with them, and we are very close in contact with the ECHA and REACH. And so the information I gave you on that slide of where cobalt is under concern is the latest information we got from the Netherlands. And actually, so we are today in category 2. So that means is cobalt and cobalt substances are categorized as reprotoxic material. You can still use it at higher dosages of 0.1%. However, the reclassification is in process and we are observing tightly because we expect a soon phase out because of the category 1 regulation in some European countries very soon as of now.
Thank you very much, Bernhard, for answering this one. And we move to the next. Barium and lithium aren't transition metals. Do they work in the same general way?
No. Actually, what these secondary drying metals are made for, actually, in the world of air drying architecture, or air drying alkyd paints, I'm sorry, is that transport of oxygen into lower film layers. So because when we have a very fast primary drying metal like cobalt, iron, or manganese, sometimes they close the film very tightly and firmly and avoid the oxygen from penetrating into lower film layers. So those auxiliary dryers you mentioned, they are then able and critical to bind the oxygen and keep them in the lower areas of the film, so that oxygen is then available also for the primary dryers, which are in lower or statistically lower film layers. And that is the support function of these dryers. Thank you for the question. It's a good one.
Thank you very much for answering this. And let's move to the next. How does manganese impact yellowing or discoloration in white paints compared to cobalt?
Yeah, this is a very good question. I thank you for that. Manganese as such would have a severe impact, I would say. It all depends on the dosage. So when we speak about generation 1 manganese dryers, so cobalt replacement dryers, we did observe that manganese has a stronger impact because the ingredient of elementary manganese was a relatively high impact. And that means we had a high discoloration rate. And the discoloration was turning into yellowish and brownish in a white paint. So what did we do then? We had to overcompensate this, or we had to kind of compensate the agility of manganese, the efficiency of manganese in respect to the drying, to the set drying, with ligands and organic accelerators. So by finding the right couple and the right composition and dosages of these accelerators, we could reduce the amount of manganese to that low level that there is no impact or very, very little impact on the white paint. So something which is state of the art, and we know we are approved with our dryers in bright white applications, even for exterior facade paints.
Thank you very much, Bernhard. And we move to the next question. Do we see the launch of 3-metal dryer soup in the market? And by soup, we mean manganese dryer plus auxiliary dryers included calcium, barium, and lithium.
Yeah. Also, fair question. A little difficult to answer, I have to say. However, our aim was always to provide the market with the best options. And the best options in our point of view, and we have engaged here a lot of formulators and experts. And our aim was actually to provide the market with a 2-component package, if you want, right? Component 1 is the primary dryer, which allows you the formulation. And don't forget, in some applications, you don't need a secondary dryer. That depends on the resin system. But in case you need a secondary dryer, you have the option to co-dose a little bit of these materials towards the primary dryer. So the combination of a CF100 as a primary dryer together with a CF200 is, you're not obligated to do that. But if your resin system requires that boost in through drying hardness development and oxygen transfer, you have something in hands that you can use, but you don't need always.
Thank you very much for answering this question. And it was the last question for you. You covered them all. So thank you very much, Bernhard, for presenting. Thank you for answering the question.
It was my pleasure. I wish you all the best. Goodbye.
Thank you very much, everyone, and see you in the next session. Bye-bye. Bye, Bernhard.
Bye-bye.